Welcome to the solutions for the volume problem. So this is a fairly typical exam question. It tells us here's a cuboid. That lets us know we can use the formula for volume of a cuboid. And it says calculate the volume of the cuboid. So really important, volume. So you've got area, volume, perimeter. Make sure you work out the right one. Of course there's surface area. That's the other thing that you can be asked for these. Now, we're not asked to measure anything. That's why it tells us you're not accurately drawn. So no measuring required. We've got to use these measurements. And to work out the volume, it's pretty simple. Volume of a cuboid is length times width times height. Now, a lot of people get in a bit of a mix-up over which one's the length, which one's the width, and which one's the height, but because you're multiplying three numbers, you can multiply them in any order, so it really doesn't matter. So it's 3 times 4.5 times 6.5, and you pop that lot into your calculator. 3 times 4.5 times 6.5, and out comes the answer, which is 87.75, and that's what goes here. 87.75. Job done. Now, it's entirely possible you would have to do that without a calculator, in which case you would multiply the two of them together and then use the grid method. Okay, question 2. Piles of words. But this is a stacking problem, of which the exam boards seem to be getting more fond. So this is telling us a company makes building bricks for children. The bricks are all 5 centimetre cubes. Right, we don't care about the children or the building bricks, but we do care that they're 5 centimetre cubes. Probably worth drawing a little sketch of one of these, because a 5 centimetre cube is, of course, 5 centimetres in each direction. And that's the important thing, isn't it? How long, high and wide it is. Okay. The bricks are going to be packed in boxes. What a shock. John designs a box for the bricks. The box is a cuboid. The size of the box is this lot here, and of course that's the box we can see here. Notice the numbers match up. And the question finally at the very end, so if you really want to know what the question is, you've got to go right to the very end of these things, and it says, will the box be big enough for 36 bricks? There's the actual question. Now, it's not enough to say yes or no. There's 4 marks for this question. If you write yes or no and there's nothing else there, you'll get nothing, because it says you must give reasons for your answer. And they've written that on purpose because they know if they don't write that, people will just write yes or no, and they'd have to give them the marks, wouldn't they? So how do we work it out? Well, lots of ways. The easiest way is just to see how many fit in, really. So this side is 25 long, so if each brick is 5 centimetres and the box is 25 centimetres long, that's 5 bricks long. So you can see you'd get 5. And it's quite hard often to draw this, so I probably wouldn't advise this. 1, 2, 3, 4, 5. You can see mine aren't all the same width, so pretty dodgy trying to draw it. Okay, so it's 15 that way. Okay, so you're going to get 5 bricks along and 3 bricks that way. Now, we come into a bit of a trouble here because the height of it's 12 and the bricks are 5 centimetres high. So 2 bricks is 10 centimetres and you can have a little space at the top. So that's just 2 bricks high. So let's see if we can work out how many bricks fit in the box. So the bottom layer, if you looked at it from above, would look like this. It would be 3 bricks by 5 bricks. 1, 2, 3, 4, 5. And you can see 3 times 5 is 15. But there's 2 layers of bricks here. So you've got the bottom layer, then the second layer, then the gap. So actually it's 15 multiplied by 2, so actually 30 bricks. So the answer is no, the box only holds 30 bricks. Now, have I written enough to get the 4 marks? Well, one of the marks is going to be for the conclusion. So that's going to be one of the marks there, but that mark won't be one without some other stuff. This is pretty important here. That's demonstrating that I've worked out how the bricks fit into the box, and the 30 bricks is the other number that's key. Obviously these calculations are pretty important, so yes, I've got enough there. Question 3. The diagram shows a prism. Now, prism, and especially where it says down here, the volume of the prism, should make you think of the front of the exam book where there's a little picture that's got a sort of squiggly shape and like that, and it says the volume of prism equals the area of the cross section times the length. And it says that right at the front of your exam book. Now the cross section is the end bit. So to work out the volume, we do the area of the cross section times the length. So let's have a look at the question. It tells us it's a prism, some numbers on it, and down here notice it says the area of the cross section is 18, so they're just telling us what the numbers are. So often you don't need to get too worried about all the writing, because the writing and the diagram match up, and this is the important bit: work out the volume of the prism. And we know that because we know in the front of the exam book the volume of the prism is the area of the cross section times the length. So pretty straightforward, eh? The area of the cross section, that's 18, because it says it here, and it says the area of the cross section is 18, and the length is 5.8, so we multiply it by 5.8, and 18 multiplied by 5.8 gives you the grand total of 104.4, and that's what we put there. Don't know why I'm writing 0.5. Worth saying actually, if you do something like this where you've got a slightly confused number, now I think that looks like a 4 enough, but if you do something that's at all confused, then the best thing to do is just to cross it out and write down what you really want the examiner to mark. So don't start overwriting your numbers, just make it really clear what answer you want marked. Question 4. Okay, well this is actually another prism, okay, but let's read through the question. A solid cylinder has a radius of 4 centimeters, so again they're just telling us the numbers on the diagram, and a height of 10 centimeters. There we go. So that bit's pretty boring really, isn't it? Work out the volume of the cylinder. Give your answer correct to 3 significant figures. There's 2 bits here really, and not a lot of marks for it, to be honest. Okay, so the volume of the cylinder, well, it's the area of the cross section times the length. Now, the area of the cross section is the area of a circle. So, twinkle twinkle little star, circumference is 2 pi r. Didn't know you really cared, but area is pi r squared. So it's pi times 4 squared. That's the area of the cross section. And then we multiply that by the length, which is 10. And we put that into the calculator. And of course you need your pi button. So pi times 4 squared times 10, and the number is 502.6548 and some stuff. Now I'm writing down loads of the decimal places because I'm going to round it, and it's best to have more accuracy than you need at this stage. So 3 significant figures. Here we go. So 3 significant. We start at the biggest bit, which is the 500. It's the first one. The second one, the third one. So we're rounding it to the nearest whole number, and when you round you always look at the next number. In this case it's a 6, which means that it's going to be 503. Okay, the challenge question with some random little bits on the screen. Now, first of all, work out the volume of this solid cuboid. So it's another volume question, so width times length times height. So 23 times 12 times 10. Okay, so 23 times 12 times 10 gives you 2,760. Okay, that's pretty boring. Now we get to the difficult bit. The solid cuboid is made of plastic. The plastic has a density of 0.8 grams per cubic centimetre. Work out the mass of the cuboid. So you have to be able to link mass, density and volume, and this is pretty straightforward. Every cubic centimetre weighs 0.8 grams. How many cubic centimetres do we have? Well, we've got 2,760 cubic centimetres. So 2,760 lots of 0.8, and that gives us 2,208 grams. And it's always nice to sort of see if we think this is sensible. It's almost a gram per cubic centimetre, so it's almost 2 kilograms. In fact, it's 2.208 kilograms. Completely unnecessary, you're not asked to do that, but notice how 1,000 grams is a kilogram. So 2,208 is going to be 2.208 kilograms. So it's actually a pretty heavy piece of plastic, that. Hope you found this useful. Good luck with your revising.